Good afternoon, Senior 2 students. We're still Chapter 2, and here is our last lesson, the oxidation numbers. What is the meaning of oxidation numbers? Oxidation numbers is a number that refers to the electric charge, either positive or negative charge, that the atom or the ion should have in the compound. And we have an oxidation number for ionic and for covalent compounds. So the oxidation number indicates the charge that found above the ion or the atom. What is the significance of oxidation number? What oxidation numbers explain to us? The significance of oxidation number differ in ionic compound from that of covalent compound, and let's understand this more in the following slide. For the ionic compound, if the oxidation number is positive, it indicates that the number of electrons that the atom lost to give a positive ion or cation. If the oxidation number is negative, it indicates the number of electrons that the atom has gained to give a negative ion. As we mentioned in the previous years, the ionic bond is a combination between positive ion and negative ion. The metal atom loses an electron and changes into positive, while the non-metal atom gains the electron which is lost by the metal and it changes into negative ion. In covalent compounds, if the oxidation number is positive, it indicates that the electronic shift in the chemical bond between the atoms is away from the less electronegative atom. If the oxidation number is negative, it indicates that the electronic shift in the chemical bond is towards the most electronegative atom. As we mentioned in the previous lessons, we have a property called electronegativity, and each element has a specific value of this electronegativity. In this case, a fluorine atom has high electronegativity with respect to hydrogen. In this case, the electrons of the covalent bond will shift more towards the high electronegative atom, which is fluorine. Fluorine will take partial negative charge, while hydrogen take partial positive charge, as it is the less electronegative element. How to calculate the oxidation number? Number one, the oxidation number of any neutral element is 0, wherever the number of atoms are. This is because the electronegativity of the atoms is equal, so the valence electrons spend the same period at each atom. Here we have two similar atoms forming a chlorine molecule. Both of them have the same electronegativity, so there is no shift in electrons. The second rule, oxidation number for element ion equal to the charge of the ion. We can look at the charge here. We have positive silver ion. Its charge is positive, so it loses one electron during the chemical reaction, so its oxidation number is positive 1. Copper here loses 2 electrons, so its oxidation number is positive 3. In case of chlorine, oxygen and nitrogen, their ions take negative oxidation number as they gain electrons. The oxidation number for atomic group equal the number of charges on the group. We can observe here by knowing the charge, we can know the oxidation number. When the group gains electron, their oxidation number will be negative values, but in case of losing electrons, the oxidation number will take positive value. The fourth rule here, the oxidation number of any metal of group 1A will be positive 1 as they lose only 1 electron. In group 2A will be positive 2 because they lose 2 electrons during the chemical reaction, and for group 3A, positive 3 as they lose 3 electrons during the chemical reaction and changes into positive ion with 3 positive charges. The oxidation number of fluorine in all of its compounds equal -1. And this is because its electronegativity is greater than all of other elements. The oxidation number for chlorine, bromine, iodine, all halogens in group 7A equals -1. The oxidation number of oxygen in most of its compounds, mostly -2. But we have some exceptions here, like peroxides, like hydrogen peroxide, the oxidation number here for oxygen equals -1. And for superoxides, oxidation number here for oxygen equal -0.5. And in case of oxygen fluoride, it's +2. The oxidation number of hydrogen in most of its compounds equal +1, but we have one exception here. Compounds called hydrides. Metal with hydrogen form a compound called hydride. In this case, hydrogen oxidation number is -1. And finally, the oxidation number of any chemical compound equals 0. And this is because the algebraic sum of oxidation number of its atom equals 0. When we do the summation of all oxidation numbers for elements that form the compound, it must be 0, and the compound must be neutral compound. Example, how can we calculate the oxidation number? Find the oxidation number of sulfur in sulfuric acid. Simply, we have to separate the atoms that form this acid. We have here 2 hydrogen plus sulfur, and we have 4 oxygen atoms. The summation of oxidation numbers in this compound must be equal 0. Step 2, substitute each element by its oxidation number. We have here hydrogen, its oxidation number in all cases except hydride will be equal 1. 2 times 1 plus sulfur, we want to calculate its oxidation number, plus we have 4 oxygen, and oxygen, its oxidation number in most of cases -2. Finally, you can get that sulfur oxidation number is +6. Find the oxidation number of sulfur in sodium thiosulfate. Separate the atoms that form the compound, and the summation of their oxidation number will be equal 0. We have 2 sodium, 2 sulfur, and 3 oxygen. The second step, put the oxidation number for each element except the sulfur. Of course, we have to calculate it. 2 times the oxidation number of sodium, +1, plus 2 sulfur, plus 3 times -2, oxidation number of oxygen is -2, equal 0. Finally, you can get that 2 sulfur, their oxidation number +4, and 1 sulfur atom, its oxidation number is +2. The third example, find the oxidation number of sulfur in hydrogen sulfide gas. Step 1, separate the atoms and put the sum of their oxidation number 0. Step 2, put the oxidation number of hydrogen, which is +1. 2 times 1 plus sulfur equals 0. So the oxidation number of sulfur in this case will be -2. Advantages of knowing the oxidation number. By knowing the oxidation number of an element, we can know the change that happens to this element during the chemical reaction. And we have 2 types of a change. If this element loses electrons, this will result in increasing the positive charge of oxidation number. If this element gains electrons during the chemical reaction, this will result in decreasing in the positive charge of oxidation number. In the chemical reaction, we have metal tend to lose one or more electron, so the oxidation number will increase. But in case of non-metals, they tend to gain one or more electrons, so their oxidation number will decrease. The substance which loses electrons is oxidized, and the element is called reducing agent, while the element that gain electron is reduced and it is called oxidizing agent. As you can see here, by decreasing the value of oxidation number, the element will undergo reduction. But in case of increasing the oxidation number, the element will undergo oxidation process. Let's take an example. Explain the type of a change, oxidation or reduction for the carbon in this reaction. Step 1, we have to calculate the oxidation number of carbon in this compound. As we previously mentioned, separate the atoms. We have here 6 hydrogen atoms and 1 oxygen, and the summation of oxidation numbers must be equal 0. 2 carbon plus 6 times the oxidation number of hydrogen, which is positive 1, plus 1 is the number of oxygen atoms here, times negative 2, the oxidation number of oxygen. All of this equals 0. 2 carbons will be equal negative 4. 1 carbon, its oxidation number is negative 2. Let's move to the second step. Calculate the oxidation number of carbon in this compound. We have here 2 carbon atoms, 4 hydrogen atoms, and 1 oxygen atom. Separate them and put the oxidation numbers for hydrogen and oxygen. 2 carbon plus 4 times 1 plus 1 times negative 2 equals 0. In this compound, the oxidation number of 1 carbon equals negative. You can observe here that the number of negative charges decrease. As you can observe here, we have 2 carbons, 4 hydrogen, and 2 oxygen atoms. And the summation of the oxidation numbers will be 0. 2 carbon plus 4 times 1 plus 2 times negative 2 equals 0. Finally, we will get that 2 carbons, their oxidation number equals 0, and of course 1, its oxidation number will be equal 0. So the number of negative charges decrease in this case. The process that happens to carbon in this equation, oxidation process. How can we know that? By decreasing the negative charge, we can say that the oxidation process happens, and carbon here is a reducing agent. After knowing how to solve or how to calculate the oxidation number for an element, explain the change of the oxidation and reduction that occurred for each of chromium and iron in the following reaction. Try to answer this by yourself. Thanks for listening, Senior 2.